Good afternoon, ladies and gentlemen. Welcome back to Math 30-2, Chapter 4, Section 8, Section 4, Equations, Sinusoidal Functions, Part 4. Finally, we're getting to the end. Now, here, next question for you. How would the graph of y was 3 cos 2 bracket x plus 45 degrees close bracket be the same as the graph of y was 3 sine 2 bracket? Why am I putting the bracket there? I apologize, ladies and gentlemen. It's just there. X minus 45 degrees. All right. So how are they the same? Well, they're both sine graphs, sinusoidal. So they're both wavy up and down. They both have an amplitude of 3. Period B is 2, which makes the period 360 degrees. 180 degrees. And yes. Now, how are they different? Well, you look at the C values. They have different starting points. Yes, this is plus 45 degrees, minus 45 degrees. And if you want to be picky, can we draw that? Yes. I don't want to because I'm lazy. 40 grams per calculator. Sine. Sorry, so the first one's cosine, so I'm just going to do, now, I'm not doing the amplitude, which I can. And both, let me see, sine graphs, cosine graph, start at the top, down, in. Now, the two curves here, the B, that. There we go. And then 45 degrees plus 45 degrees means it starts over like here somewhere. The other one, sine of x, 3 sine of x, like that. Then what happens? It gets squished, half the size. There we go. And then that minus 45 means it moves over. Oh, you presidents of that. It moves over here. So it'll be something like that. Now, if you want to spend the time drawing them, you can. You realize they just have different starting points. Okay? Now, I'm hoping you're getting that. A couple more examples and I'll be quiet and leave you alone. So here. Match each graph with the corresponding equation below. So, oh, crud. We have cos or sine, and remember the only real difference between cos and sine is where we start. Alright, so let's look. What do all the sine and cosine graphs have in common? A equals, B equals, and B equals. So let's look at these graphs. So, let's look at this one here. Okay, so eyeballing it, where's my midline? Let's go down to minus 3 and up to 5. So my D value for this one is 1. Is 1. So for this one, it can't be this one. So let's start. And what is my A value? From 1, A equals 4. And that doesn't want to be there. So let's look at B value. What's the period of this graph? I'm going to cheat. Oh, you fucking nugget. I'm looking at the numbers here. Well, stop that. People are watching. I want to go here, peak to peak. I think that's easiest. Because I start at 90 degrees. And I end here. 30 degrees, 210. So that gives me 120 degrees. Period. 120 degrees, which is 360 degrees divided by B. So cross multiplying, we get 360 over 120, which that a 4 sine? Okay, now this is getting annoying. So, here we gotta go, where do we start? So, if this is a sine graph, it starts at c equals 60, so it starts at 60 to the right. So it's 60 degrees at the start of sine graph. Yes, it is. So this is the one, this graph here. Now just to prove it, this is minus 60 for the cosine. That minus 60 is the graph up here at the peak. No, it's not. All right? So I'm going to stop a minute. Let's think about that. I realize here I can use the same equations for the next one. So let's look at this last one. This one here. I'm going to pause the recording. I want you to calculate find A, D, find the period, and figure out B just like I did here. Okay, so pause the recording, do that, come back, and we will compare answers. Okay, ladies and gentlemen. So here, I volume D is 1, amplitude is 4, my period, the whole wave is 360 degrees. Now, technically, I should calculate B because 360 degrees divided by B, which is 1. So, let's look at these equations down here. Amplitude of 4. D is 1, and period, B is 1. Okay, now to prove it, I should, since this is nothing, it has to be times 1, just double check, does this start 90 degrees to the right? So if we go 90 degrees, does that look like the start of the cosine wave? Yes, it does. So that's the correct answer. Now, so far so good-ish? Well, I hope so. Oh, come on, next page. Last example question. The number of hours of daylight in a calorie Nunavut can be represented by the function y equals 8.245 sine of 0.0172 bracket x minus 80.988 plus 12.585, where x is the day number of the year. Now, how many hours of daylight occur in calorie on the shortest day of the year? Now, right off the bat, note 2 things here. The brackets here, leave it like that for the moment. When you're graphing, it's a math 30-1 thing. Just leave the bracket there. How many hours of daylight occur in a calorie on the shortest day of the year? That is the more important question. This is the minimum. That's D minus A, which is 12.585 minus 8.245, which is what? Now, Mr. Calculator says 4.34 hours. Holy poop. That sucks. 4-something hours a day of the year. And then the shortest day of the year. We get like 7 or 8. Oh. Longest day of the year. I guess I should change colors here. Like that. Red. It stands out a little more. Longest day of the year. That's the maximum. D plus A. So 20.83 hours. Oh. That's a lot. Okay. Okay. And I'm going to skip that question because it's a diploma thing. Question is, what's the period? Okay. Now, this is both simple and tricky. This is, we can look at the equation. I have the B value right here. Change the color. 2.0172. Right. Now remember, period is your should be 2 pi divided by your B value. do all that work and then realize we're talking about sun in the year. What's the length of a year? 365 days. Please, 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 please. The 2 pi. Wakey. 2 pi. 5 by 0.0172. 365.3. Close enough. Probably 0.01719 something like that. Now, what happened there? Oh, I wrote this answer on the wrong page. My apologies, ladies and gentlemen. Getting old. So I said we're skipping that because it's dumb math and I don't want to do it. Now, last question. What's the value of C representing this equation? Come on, stop that. People are watching. C equals 81. Well, that's a start. That would be shortest day of the year, the longest. Oh, sorry. Because you start, he moves in 81 days. After the start, the year. This period starts. So like 81 days in would be the shortest day of the year, which is in March. That's odd. It should be a little, or whatever. But that's what the equation says. Anyway, I'm going to stop there because we're running out of time. Can you look at the equation? Can you read it? Can you tell me information off the graph or off the data, off the equation itself, rather than getting lazy and graphing it? I hope so. Any questions? Shoot me an email. Otherwise,